Hello, today we're speaking with Robert Schmitt, founder and CEO of Vultus. Welcome to Podcast Robert.
Thanks.
To start with, could you tell us a little bit about Vultus?
Sure. Yeah. So Vultus, our mission is to help farmers get better yields with lower costs. So we do that using satellite remote sensing. So we help our farmers to apply their fertilizers more efficiently using satellite analysis. And we deliver this through an API to different actors in the ecosystem. So this way we're connected with lots of different apps, and that way you get a lot of exposure to farmers. So we have about 1 million acres currently using our products.
Amazing. And where are those acres? Are they mostly in Europe or?
Yeah, so we're currently focusing on Central and Eastern Europe mostly. So we have some operations in UK and the Nordics, but also in Russia and Romania and Ukraine. So I think that those are kind of our core geographies where we're focusing right now.
And are you, I suppose, focusing with those geographies on like these kind of vast, winter wheat fields in the likes of the Ukraine, or, I suppose what particular crops do you kind of cover with your technology?
Yeah, exactly. So our technology is best adapted for kind of the large scale sort of commodity crop farming. So I think here in Europe, wheat, barley, canola, those are, I think, the biggest crops in general. But we also have to support some other crops as well. So things like potatoes and most of the sort of major commodity crops we've tried to build support for. So things like also like rice and some specialized types of wheat and so forth, and then also some vegetables.
And what drove the initial decision to start Vultus?
Yeah, so I've always been quite entrepreneurial. I have had sort of some small sort of personal businesses when I growing up. So things like I collected like golf balls at a sort of, we lived next to a golf range, and I used to pick up golf balls that were out of range. I also had a video game consultancy company when I was in high school. And so when I was at university, I was studying law, and it was really quite boring. And I wanted to do something more technical. So I was actually going to switch to engineering. And before I was able to do that, I had a friend who had a drone, and we tested different things to do together with it. And we tested with farmers, and that's kind of how we got into this whole area of, okay, we found out that there's actually a huge need to map farms and to get data about what's going on in the field. So that's kind of what got me started into it. And then basically I passed my studies and pursued this full time. So yeah, that's how things started.
And where did you find those kind of early users for that like initial MVP?
Yeah, so I mean, the really initial test, so one of them was my friend's grandpa, and then we called up just we looked on Google Maps, and we found some pretty big sort of potato farmers, and we called them up and just kind of tried to find or see if they, were interested to have their fields mapped, and this was in 2016, and drones were really quite hyped then, and farmers I think they're usually quite interested in sort of mechanical things and new technology as well. That's kind of mechanical, and so I think there was quite a bit of interest to test the drones and to see what you could get from it. So that's kind of how we got our early users. But it was really just quite a bit of cold calling and finding someone who wanted to have us.
And from that kind of early stage to now, were there any pivots along the way?
Yeah, absolutely. I mean, so we don't work with drones anymore. And I think that kind of story of how that came to be is pretty interesting. So the first growing season that we worked with or the first year that we worked with drones, and our ambition was to kind of create this kind of globally scalable service where we would offer kind of drone services to farmers and give them recommendations based on that data. But what we found was that it's extremely difficult to scale drones, and it's really quite expensive. So we had a lot of really long days where we were trying to map a lot of different fields. We were driving around everywhere, and then we would find out that some of the data, like the drone had like flown in a slightly wrong way, so then we had to get up like next day super early to map the fields again and so forth. And it was just a really huge hassle to execute that model. I think things have definitely improved since then, but it was really, really challenging. So that's kind of one of the biggest pivots we did was, we completely changed the identity of our company to switch from drones to satellites. And that process was interesting, but I think we're happy we did that transition, and we did it during a period when it was really unpopular. Most, we had a lot of people, like even people on our team and also like investors and so forth, that were like, drones are the big thing, and like, of course you should go with drones. But I think later on we realized that we're really happy that we made that pivot. I think now it's quite clear that I think this type of use case, I think the the best technology is using satellite technologies. And I think we're happy that we took that decision then, and that we've been investing in this technology tree instead. So yeah, that's I think the biggest pivot. But we've also done other pivots throughout the way. We're happy to dive into those as well.
Yeah. So before we get into those, what I suppose are the main kind of pros and cons of using satellite imagery versus drone imagery?
Yeah, so that's something which we really dove pretty deep into. So I'd say the benefits of satellites is very low cost and global scalability, and also really standardized data flows that have been developed on for many decades. So I think those are kind of the key benefits of using satellites, and I think kind of that type of characteristics and feature sets is really very well aligned with farming, or this kind of large area farming. So the benefits of drones would be that you can have really high resolution data. You can also kind of specialize the sensors you have on. You can decide when you want to collect the data, and so I would say, but it comes at a cost of both. It's very expensive. You need hardware. The data processing is really expensive, and it's really not very scalable. If you have really large fields, it's very challenging. And it's also, if you want to map a lot of fields, it takes a lot of time. So you kind of have those benefits of it being really specialized. And there are some use cases where that's actually very desirable. So I would say, for example, if you have a vineyard or you have some other very high value kind of low area crop, I think their drones are very worth using. I think also other applications outside of agriculture where you need that high resolution, you need that flexibility, it's definitely, there's a lot of pros to it. But I would say when you talk about low margin commodity crop farming, huge areas, you want global scalability, I think it's kind of obvious there that the data source that's better there is satellites. And I would say if you dive into then kind of the quality of the data and how that differs, I would say actually you have some benefits with satellites because it is so standardized. You have so much development on it, and you can really kind of do the same analysis over and over again. As opposed to drones, you have some challenges with calibration. If the sensors are tilting in different ways, different sort of shading, and where the sun is, what angle it is at, you have a lot of things you have to correct for. And I think we've also found from an analysis perspective that you actually get better quality for this type of use case using satellites. So, but we also tried planes and some other things as well. So it took us a while to get there, but I think those are the main reasons, or I guess pros and cons of using satellites versus drones.
Yeah, it's interesting. I think about that kind of growth of how hot drones were, those 4 or 5 years ago. It didn't seem to kind of take into account like the margin that any sort of processor of mass data would have to kind of add margin to the relative size of a piece of land. And so, you mentioned like orchards versus, vineyards versus, row crops. Like if you have to charge a penny an acre, and like that's the margin you have to work with, or a dollar an acre, whatever it may be, you're really going to struggle in the kind of clash between something that's going to drive $100,000 an acre versus $5,000 an acre in terms of like the total crop that will come off that acre.
Yeah, exactly. I completely agree. I think it's kind of if you grow wheat, it's like a game of saving pennies here and there and really optimizing your costs because it's so competitive, it's so low margin. I think it's really a different game, and I think that's kind of that's what we're focusing on, and that's what we're targeting. So of course, then we should use the tools that fit for that use case.
And you mentioned some of the other pivots. What did those entail?
I would say maybe the second one that was quite big. I guess there's two, or they're kind of connected. So initially, our idea was to sell directly to the farmer, and I think that's something which we tried, and the reason we gave up on that is, or we shifted from doing that to working more with sort of channel partners and distributors, is kind of tied to the delivery model we have. So before we wanted to have our own digital platform, and we wanted to deliver directly to the farmer, sell directly to the farmer, and own the entire relationship. I think you can definitely do that, and I think it's not that that's a bad model in any way. However, our ambition was to build kind of globally scalable infrastructure. We wanted to be present in many geographies. We wanted to build really, really strong technology that can be leveraged by the industry and really support the industry. And it's really a lot of work to maintain relationships with directly towards farmers in a lot of geographies. It's really, really challenging. You need to be present on site. You need to visit all the farms. You need to have a very significant sales force. There's a lot of upkeep to those relationships as well. And I think what we realized was that we would rather work with the community, work with the actors that already have that relationship, that already have those kind of channels built up and that are specialized in that, and then instead help them with technology and help the ecosystem to use this technology in better ways. So that's kind of one of the big pivots we had, and that led to our pivot in terms of our delivery model, also delivering through an API. So by connecting with digital platforms, we support those platforms using this type of data, and so we support those other actors in the ecosystem, and so it's a completely different delivery model as well.
Yeah, there's a lot of interesting elements there. I suppose the first kind of thought is, like, I absolutely think that that approach to working with channel partners is something that I think a lot of agtech companies struggle with. I think everybody wants the fancy set of dashboards and application, but when you're fighting against some quite large monopoly players, sometimes if it's possible to kind of leverage the existing sales teams that those companies have, especially for an early stage startup, like, there are huge advantages to that. I mean, there are limitations as well, right? Because you're somewhat dependent on those channels. So it's quite interesting that you kind of made that pivot. I suppose, like, so in terms of the specific kind of pivot in the go-to-market, so did you have to kind of restructure your sales team? Did you have to bring in a different type of person to kind of sell? I suppose, how much work had to be done internally to make that change?
I would say for that specific change, probably not that much, because at that point we were still a very small team. It was kind of just the founders, and I think we or like the team that was there initially, and I think we've always been kind of flexible in terms of what we're doing. We don't have a long history of selling either towards farmers or through channels. So I think making that switch wasn't that bad. I think it's honestly significantly easier. Like, as a person who, like, I didn't come from farming per se. I grew up sort of on the countryside, but I had a lot of friends who have that type of background, but I didn't grow up as kind of from a farming family. And I think it's significantly easier to work with other software companies or work with other types of distributors than it is to sell directly to the farmer. I think that is something which it's just a lot more challenging unless you're really into that and you're part of that community. So I think it was actually, it just made it easier to operate, and I think it was kind of more of a relief for our team than it was a challenge in that way. But for the other pivot in terms of the technology, there we had to do a lot of changes. Yeah.
And so, in terms of the API, so, I suppose from my understanding, you would have, let's say, some large agribusiness, they have some sort of, application that a farmer is using today, like a precision agricultural or farm management software tool. And, that company, can basically use the API of your data set, that's specific to that farm, and then build a software product around it, or are they just presenting the data, or how does that work?
Yeah, so it's flexible. You can do both, and I think the idea we have is that, or I think our view of how most of these kind of local software companies operate is that they're oftentimes not the best at this type of technology, and they have oftentimes a legacy business. So either they have some sort of consultancy business, or they're selling hardware or some other things. And oftentimes they want to get exposure to this type of precision farming technology. They want to be able to sell that. So we're just trying to make it very easy to onboard those types of services into your platform and to have those features available. However, we also work with platforms that are, really great software companies and want to, build everything themselves and want to use our infrastructure to build other geospatial tools and to build new services, new features, and that's also possible. So it's flexible that you can do both. But I would say we've kind of probably spent more effort in terms of making it very easy to get going, because we find that a lot of platforms don't want to invest a really significant amount of effort and time and so forth into building out that type of technology stack. They just want to have access to that technology without that massive investment.
And then, interestingly, on the again, I'm a big proponent of APIs as as a method across a lot of industries, especially ag tech. But one of the kind of limitations is that you're in essence gaining a sales channel or like a distribution channel, but you're losing a bit of branding, right? Like, the end user of your data potentially might not know. Like, is there any kind of ways that you kind of work against that, or is there like a powered by Vultus aspect to the API, or is this more, from the farmer's point of view, this is like a white labeled service with the primary software provider that they're dealing with directly?
So it's a little bit of both. I agree. I think that is definitely a challenge, and I think that's something which we're working more and more on to make sure that kind of the branding materials and everything is consistent, because it is really important that our brand is known as well. We do have in some situations, the option to work with us white label at a cost, but I think in general we try to have kind of branding attached to it. We also we help in terms of how to sell the services. We help in terms of the content. We do joint promotions, things like that. So I would say it's kind of a mix between, just an API, do whatever you want with it, and kind of a more deeper distribution relationship where we actually partner together. So I'd say it's more closely to that kind of partnership model where we're actually working more closely together than just, here's an API, go ahead. So I'm not sure if that answers the question.
Yeah, no, absolutely. And in terms of like the actual kind of applications of, the data you've collected and processed, what are some of the things that a farmer could do with that information?
Yeah, so I would say kind of the biggest feature is we can give you a recommendation on where you should apply more or less of your nitrogen fertilizers based on both satellite-based observations of your soil organic carbon, also based on the nitrogen uptake in the plant. And all these things are crop specific and specific to your crop phenotype. So giving a really precise recommendation, you can use that to spread the fertilizers, either have it as a prescription file that automatically varies the output, or there's other methods to vary distribution. So that's kind of the biggest feature, or the most valuable feature. We also have independently our different measurements. So things like soil organic carbon, I think there's a lot of interest to measure soil organic carbon, and that's a really interesting measurement. We also have the plant health measurements, moisture. We're soon coming up with productivity zones, and we also have one of our kind of USBs in terms of our technologies that we use, something called synthetic aperture radar. It's a type of microwave remote sensing that penetrates clouds and means that we have data regardless of cloud conditions. So, there's lots of different sort of measurements about what's going on in your field that you can use. And you can use that to, guide where you're scouting, detect where you need to take different actions, track kind of your soil health, how it's going, if it's improving, decreasing, so forth. But I think kind of what we're really passionate about is how can we get this closer to actually, making a decision. And I'd say there we've come the furthest with nitrogen recommendations, but we're looking to use those measurements and all the different features that we developed to build additional recommendations. So one that comes to mind is, for example, fungicide recommendations. We have all the tools necessary to build those recommendations, also with irrigation, and we're kind of developing that, and it will come probably this year or early next.
So in terms of the recommendation, does the farmer state the kind of end goal? So, I want to reduce my nitrogen inputs by 20% this year. And then your data kind of looks at that and says, okay, relative to all the information we know about this farm using satellite imagery, that, apply most of your nitrogen in fields 1, 2, and 3 and none in 4 and 5. And that's how you make that cut? Or is that a rough approximation of how it works, or something else?
Yeah, but it's field by field. So it's we don't look at kind of the entire farm currently, but we look at kind of on a field by field level. Kind of the farmer has a goal of this is how much fertilizer they can apply, and we basically give a recommendation of how they can apply it in the most efficient way. And usually, our goal is to produce have as much production with as little waste as possible. And I would say we're not optimizing necessarily for reducing the fertilizer use as much as possible. I would say, in general, it's good if you can use less fertilizers. However, in most cases, you also have really significant production goals, and it's really important to reach those goals. And that is the priority. The priority is not always to reduce the fertilizer use, but that's oftentimes a result. So you can both get a production increase and a fertilizer reduction. But yeah, so it's a balancing act between those two things. And as a user, you can kind of tweak it a little bit how you want it. If you see that our recommendation has an output that is a little bit lower than what you had expected, you could always kind of increase the initial input. So there's ways to work around it to either get it further up or down. So the user is ultimately in control of what they're going to apply on their field and what rate is appropriate for them.
And do you have any feedback loops from the actions the farmer then takes? So, for example, you've given this kind of recommendation for the amount of nitrogen to apply in a specific way to a specific field, and the farmer may or may not do that. But if they do that, does and I presume the plants then respond in a specific way, and let's say they are slightly off what you would expect, right? Either pro or con. Does that then get kind of reincorporated back into the model?
Currently, no. It's definitely on some level, yes, when we have, for example, trials and things like that, they're working with. But I would say if it's kind of a normal commercial usage, then no. I would say the challenge is it's very challenging to get kind of the what happened in the field, kind of the results of the yields, and get that measurement kind of in a reliable way. Because some farmers have yield maps, but most don't. And the ones that do have yield maps, it's oftentimes challenging to trust that data due to different calibration issues and things like that. We have a plan to actually get to that type of feedback loop. And that's something which we have in our pipeline. So, and that plan, I could go into it a little bit if you want.
Sure.
So it's basically, we call it sort of trial automation. It's basically to get the feedback loop, we need to be able to automatically kind of generate different types of trials or like tests in the recommendations we provide, similar to how we have an A/B test. But it doesn't have to be just a strict, you split the field into half, but there's different ways to do it. And then you need to be able to, from space, assess if what the results were. So you need some sort of remote yield estimation. And that's why we have, for example, the productivity zones that are coming out at the end of this month. That's an important feature for that. And then the last part is you need to actually detect if the recommendation has been applied properly. And that's actually a pretty difficult problem. So how do you know like what the farmer did? And there's different ways to get around that. We have a method that we're developing, but putting these three components together, we should, in theory, be able to, at scale, produce recommendations for example, test users, things like that, and then get the results from that from space, without any type of data provided from the farm or anything like that, and also verify that they have applied the recommendation correctly. And that would enable us to basically scale up that type of feedback loop, I would say, and be able to, do a bunch of testing on different algorithms, different designs, and really optimize the entire our entire kind of development operation in that regard. I think that's something which, it's kind of the holy grail of like, that's something you really want to have. It is definitely a very challenging problem to solve. I don't think anyone has I don't know of anyone that has come close to solving this type of thing, and anyone that has that type of system yet. We think it would be very valuable to create. I think it would really create a massive ability to optimize these types of algorithms, because right now it's very difficult to optimize algorithms. You're using very limited data to do it. And I think having that access to data would really, really make it a lot better.
Yeah, I mean, when I think about like the kind of data story at the farm level, I call them wild and weird, wonderful data sets, right? So you have, some old kind of soil sample data that's maybe, done in different parts of the field in different ways. You have maybe they, played around with drones, so they might have like these 2 year of drone data from 4 years ago, which may not be of any value whatsoever. They may have data coming from the farm management systems they're already using. And then they have their own kind of internal records of application of fertilizer and all those kind of things. And it's all like super rich, right? But yeah, making sense of that in a way that like helps calibrate like these larger scale models, definitely like a massive problem to solve, and a very valuable one if solved.
Yeah, I agree. I think it's like you have even less data about like testing different algorithms. So like testing one versus the other in a certain environment. So that's where it's like you get to a point where there's almost no data about that, because most farmers aren't going to test two different algorithms and figure out which one is the best. They're just going to test one method or not a method. And so I think it's really unstandardized for the data you have already. But when you get to that point where you actually want to optimize different types of algorithms, it's even worse. So yeah, just want to have that said.
And in terms of the monetization model, a lot of API companies are charging per pull of the data in some format. Others use a subscription model of some form. What is your monetization model?
So we charge per hectare per year. Basically, we want to kind of simulate how these types of services are generally sold towards end users. So we find that most if you're getting soil sampling, you're getting, advice about precision farming, things like that. In general, you're usually charging per hectare or per acre per year or per month. So that's kind of the business model that we have as well. It makes it easier and more predictable for our clients when they want to then sell it to their users. And we have kind of already clear models of what the pricing models and things like that make sense for different regions. So that's usually how it works. We're also experimenting with it. For some of our services, it makes more sense to have it per request, and we're kind of getting into that as well. But I would say at this point, the core model is per hectare per year.
And what are your kind of let's say 1 to 3 year goals, or the particular kind of milestones you're trying to hit as we go into 2021?
So we want to kind of increase the usage and the scale of usage of our services. I think that's kind of one of our core goals. So I mean that's just expanding in more geographies, going deeper into geographies we already are present in. I would say the second thing is really developing more, complementary recommendations. So I think a really obvious one is fungicides. There isn't that many services available for that right now. Also, irrigation. That's another one which we're working on. And then I would say thirdly, kind of a little bit longer term goal is that we want to kind of build like a full farm model. So basically the full model about what's going on in the farm and make that scalable. That is kind of that's been kind of the goal from the start to do that. Or from very early on to do that. And it has required a development of many different features about the farm. It also has required a lot of R&D into these types of models, and the whole trial automation thing is also something we need for that. So I'd say kind of all the puzzle pieces kind of are building up towards that vision of building a full farm model. And we think that can kind of really optimize your entire farm management and really kind of make it just, you have this goal, you have these circumstances, these resources. This is exactly how you should plan out your farm. It will be dynamic based on what's going on in the season, based on all the latest measurements. That's kind of what we want to get to. So, and we have several projects on the way to moving in that direction.
Yeah, no, I love a lot of what you're saying there. One of the aspects of the product that you kind of mentioned earlier was this idea of kind of soil carbon measurement, and that's become very hot with the talk around soil carbon sequestration and regenerative agriculture and so on. So, what are your kind of general views on soil carbon markets and the like?
Yeah, I agree. I think we initially developed the service just to have it as a measurement for our nitrogen model, but then we simultaneously this whole kind of soil sequestration, carbon sequestration thing kind of became a big thing, and so we have actually involved ourselves in some projects in that area. I would say I think it is something which can definitely work. I think there's definitely challenges in terms of validating that the carbon is actually being stored and that it's being stored long term and doesn't just kind of go back into the atmosphere. I think definitely kind of what we're working mostly on is the validation aspect of trying to in a scalable way measure what's going on and measure kind of continuously how much carbon is there. And I think our tool can be helpful in that regard. I think there's also challenges there with how do you scale those measurements and making sure that those are cost effective as well. You don't want to get a little bit of money for your carbon credits and then have half of it taken up by a soil sampling budget. That would definitely not, that would reduce the use case. So I think challenges are, finding scalable ways to validate that things are right. I think there's a lot of really smart people and really smart projects developing, tools in this direction, but it's just a very hard problem. It's not easy. These are processes that are very difficult to predict. There's a lot of kind of randomness and things going on with with climate. Like you're interfacing with climate, you're interfacing with all these really complicated processes, and it's difficult to model it, with limited data. And I think they're kind of having scalable data sources will help in that regard. And that's what we're trying to do, is just how can our data be useful for those types of models? How can we help those types of projects to get further along in their work? And I think that's useful, and I commend everyone who's working on that. I think it can definitely be a great solution if we can get it working.
And recently, as part of COVID and some of the kind of recovery packages, the EU has announced some pretty major investments in anything to do with climate or carbon sequestration. I think there's $1 trillion number being thrown around. I was just, what are your views on the role of regulation and government to kind of create positive tailwinds for the deployment of technologies like yours?
Yeah, I think we've definitely benefited from some of those types of funding. So we've received a significant amount of sort of soft funding in the past and are continuously being funded by that. So, I mean, in a way, I somehow doubt if we would actually be around if that type of funding wouldn't be available. So, having that said, I will then, of course, have a little bit more positive mindset towards it. I think definitely regulation will be key towards kind of stimulating the desire towards changing. I think if we don't have if we have these negative externalities from some aspects of farming and they're not at all being sort of taxed, or there's no kind of repercussions from that, then it's going to be very difficult to change those behaviors. I think it's difficult to ask a farmer who's kind of really struggling to survive in many cases, have really thin margins, are working extremely hard to kind of make ends meet, to have them prioritize, for example, environment and things like that. You need to create a system that incentivizes that, and where a farmer who who does things that are more sustainable and where it meets the sustainability goals of the European Union, that those farmers also get rewarded. So I think regulation does play a role both in stimulating that type of behavior, but I also think that they play a role in stimulating innovation towards that area. I think a lot of these problems are very difficult to solve. These are kind of long-term, things that are very high risk and where the reward is really huge for society, but it might not be the most efficient way to deploy capital. I think in those cases, it might make sense for the EU to step in and try to fund those projects or to help accelerate those types of developments. And I think that's kind of what's going on. I think at the same time, it shouldn't go too far. I think private actors can also play that role. And I think private actors, for example, US have definitely accelerated the US, like the US agtech space is, I would say, far ahead of Europe's, but despite there being a lot more public funding here. And I think as long as the public funding doesn't crowd out the private funding, I think that's maybe one of the risks of this type of structure.
It's interesting, like the public-private funding. I know the US model a little bit better than the European model, but it's even I've talked to a few other founders who, similar to yourselves, even in the US, they got their first start because they were just really good grant writers, and they got a United States Department of Agriculture grant that first 80 or 50K to build the MVP before they went on and did the more kind of, I suppose, at least in the US, traditional VC route and kind of goes for different seed rounds and so on. I believe you also kind of have brought in kind of private capital. Like, what was that process like?
Yeah, so we've done both. So we've done grants, so that's kind of how we got started, how some of our initial funding, and then we actually did equity crowdfunding and some angel funding, and then we did our last kind of round was a VC round with three Nordic VCs. So yeah, I mean, it's definitely challenging to raise funding as an early stage company. I think it's not an easy task. I think you see a lot of headlines of all these rounds being raised and so forth, and but it's definitely a lot of work. You need to develop the relationships with the different VCs. You need to have a good case. You need to be very proactive in terms of reaching out to VCs, keeping those VCs updated, and building momentum towards your round, and then ultimately closing it. I think there's a lot of things that can go wrong and that can kind of torpedo your round, and I think we're very happy with the investors we got on board. I think they've been very supportive and helped us a lot in terms of our growth. We were happy that they're on board, but it was definitely not the easiest task in the world to get them on. Definitely took a lot of work to get there.
And how much of that is due to, I suppose, location, and I suppose your general views on building a startup in Sweden specifically?
Yeah, so I've only built a company in Sweden, so I think, although I have some exposure to US and so forth as well, I would say I think there is definitely a lot of investors in Sweden. I would say there's a lot of VCs. I would say Sweden, and I would say especially Stockholm, there's a lot of unicorns that have come out from there, and that has kind of created a lot of this kind of, I would say, similar type of mindset as you have, for example, in Silicon Valley or something like that. But it's at a much smaller scale. I would say there's much less capital. I would say the valuations are much lower. I think in terms of building a business in Sweden, I think specifically we have to be very cautious of regulations. We're very heavily regulated from like an employment perspective. I think that kind of goes for most of European Union and probably many states in the US as well. But you have to, there's a lot of rights you have as an employee. You have to, if you violate any of those rights, you have this really powerful, union that can really mess you up. So you really have to abide by all the laws and be very careful to make sure that you follow those laws. But yeah, I think, from that perspective, I definitely wish I was, to some extent, I'm happy we were founded in Sweden. I think that there's a good alignment with kind of the values we have, with kind of how we want to run the company, like what we want to promote and kind of who we want to be. But at the same time, I think it would be, with some of those challenges, I think it would probably be easier to run it from a different country. I'm not going to lie, I'm very thankful for everything we've received, everything we've gotten and where we are. But if I would start my next company, it might not be in Sweden, just saying.
Yeah, it's interesting about the kind of, worker kind of elements or the balance between worker and capital. I was reading an article recently about, you have a lot of people leaving the Bay Area, a lot of investors leaving the Bay Area at the moment, moving to places like Austin and Miami. But I read this great article about how, Austin and Miami, have interesting tech scenes. It's going to be very difficult for them to get to this scale of, the Valley, mostly in the terms of this article, because those states have non-competes and they respect non-competes, whereas California doesn't allow non-competes. And it's a really interesting kind of value because, when you have a non-compete, like that's a restriction on a worker's move. That's, at least in a technology company, probably more debilitating than some of the other kind of workers' rights elements. And so, yeah, I'm from Ireland originally, and when I talk to kind of founders back there, I talk to some couple of policymakers I know, I'm always like, you got to remove those non-competes, otherwise you're never going to get a Dublin-based Silicon Valley or anything like that.
Yeah, I mean, we do have non-competes ourselves, but I think for us, it's not that that problematic, because most people who work in agtech, like most of the people aren't gonna. There isn't that many kind of competing services that they would probably work with, and so I think it's not as problematic in our case. But I agree. I think there's a lot of things that go into a good environment and making it easy to run a business. I think kind of having, I would say the one thing that I find is problematic here is that you have a lot of regulation that is unclear and difficult to abide by. And if you don't abide by it correctly, you get punished, heavily. And I think that's something which, as a small company, I think that's something you have everywhere. Like, you don't want super complicated regulation that you can't follow, or where you need to have a bunch of legal fees to make sure that you can follow them. And I think that's something which is always sad. And that, I think if non-competes become that, I agree, it can definitely be more of it can break innovation instead of encourage. And I think it's good to have ability to move around, to not be stuck and not be able to work in any sort of tech company or something like that. I think that could be super problematic. In our case, I think it's not as bad, but definitely I see where you're coming from in that regard.
Yeah, no, I absolutely think regulations should be very dependent on company size. Like, honestly, below 100 employees, like, it should just be a very different landscape than a company with tens of thousands. And yeah, it's very similar in a lot of countries where you have the same, whether you are a Fortune 500 or whether you are two people in a garage. And and to be honest, like, even things like GDPR, which I'm generally a proponent of, and I've been the head of security at other startups. Those definitely favor the large companies because, they have full department to manage GDPR and similar things. But yeah, it's definitely kind of a complicated kind of picture. But yeah, just here before, this has been a great conversation. Really, loved chatting to you, Robert. Before we finish up, is there anything I should have asked you about but did not?
No, I think that was good. I think we covered a lot of ground. It was really good questions from your side as well.
Well, thank you very much. Thank you, Robert.